questions. So this is our student panel seminar specifically on advanced tracks and research. If you're here for more competition related content, we may talk about that a little bit, but we also ran a seminar recently specifically on competitions. So feel free to send us a message in the chat. We'll make sure you get that recording as well. But just a little bit about why we're here. And one of the themes we really want to explore in this seminar is this research program, MIT Primes. It is Boston-based because MIT is a school from Cambridge in the Boston area. And all of our panelists have participated in this program at one point or another. So we'll be tossing this term around a lot, MIT Primes. It has a nice long acronym, which is Program for Research in Mathematics, Engineering, and Science for high school students. And it is a research program for high school students within driving distance of Boston. And I won't speak to this too much because all of our panelists have much more intimate knowledge of this than I do. But one of the questions I already saw come up in our registration is whether there's a remote option for research. And so Primes USA is a similar remote option, also run by MIT. So program participants can work with existing MIT researchers on problems in any of the science fields, mathematics, computer science, computation biology. And we're right in the application period right now. Actually, when I looked it up for this year, it's November 30th. And if any of your students are looking to participate this year, now's a great time to apply or just to know about for future. This is kind of the time of year when that happens and then take place throughout the calendar year. And so I'll share a little bit about our panelists and then let them all introduce ourselves. So our panelists are all current or former KTBYTE students. I actually think all former at this point, though you did all learn with KTBYTE for a long time. And we're some of our top teaching assistants, junior instructors as well. And other than this specific research topic, you all have experience with our advanced CS coursework. Some of you have advanced robotics or competition experience too. So yeah, just wanted to say we're very proud of your accomplishments and very grateful that you can be here. And maybe I'll just call on each of you to introduce yourself. Maybe if you could speak a bit to how you started learning computer science, how you first got into research, and maybe just a fun fact about yourself. It doesn't have to be CS related. So maybe Maddie, would you like to go first?
Yeah, so hi everyone, my name is Maddie Yablon. I guess I've been a student with KTBYTE since I was in 7th grade, and I help as a TA now. But I guess I got interested in computer science when I was probably going into 6th grade. I went to like a camp about Python, like where we just learned some Python, and that was where I had my first exposure. And then afterwards, I really cultivated my love for computer science with KTBYTE, learning a lot of like Java and processing. And I guess regarding computer science research, I heard about the MIT Primes program actually at a KTBYTE open house. So that was when I heard about it and I got interested in it and I applied. And I'm doing it now. And I guess a quick fact about myself, I have 2 pet gerbils. Yeah.
Awesome. Thanks so much, Maddie. And maybe we'll go Alvin next.
Sure. Hello, my name is Alvin, and I initially started CS, I think, because I was into playing computer games as a kid. And so back in, I think also around 6th grade, I wanted to see if I could make my own. And so I started with a bit of Scratch and then quickly moved on into Python and then later Java. And then I self-studied until joining KTBYTE in 8th grade. And I took one of their machine learning classes, and I think that introduced me to the idea of solving what is not known. And so I think there's a lot of research experience you get there. And then I applied to the MIT Primes program right after. A fun fact about myself, I used to raise caterpillars, I guess.
Oh, wow, that's a very fun fact. And yeah, thanks for mentioning our machine learning course. That is something that we're happy to answer questions about. I think at least Alvin and Tanisha have participated in that course, and I'm currently instructing it, so I'm happy to speak about that at the end as well. Tanisha, would you like to introduce yourself?
Hi, my name is Tanisha Saxena. I was a KTBYTE student from 6th grade until like my junior year in high school. My computer science journey started maybe when I was in 5th grade. I took a summer camp that was like Minecraft modding in Java, but it was only a summer camp and they didn't teach over the year, and also it wasn't that great. And my parents heard about KTBYTE from when they were starting out. They attended one of their information sessions and they decided that that was something they wanted me to do. So I did it, and I learned so much more about computer science. It was really a lot. I started from like CSOOA, which was like basics for people my age, and I went up into their Musical Gold course, and I learned so much from them. And then in my sophomore year of high school, I applied for MIT Primes, and I did it for 2 years. Yeah, that's mostly my my experience with research in high school, and now that I'm in college, I do research here as well.
Awesome. Thanks so much, everyone. And I figure from there, we can launch into some panel questions, which I have a running list of. We're also happy to take questions in the Q&A or in the chat. And if you submitted a question during registration, we'll be getting to those at the end as well. So we've already covered a bit about what MIT Primes is in general, but I was wondering if any of you could speak to, for the MIT Primes application timeline and any suggested prerequisites, things you were really grateful to have already learned when you started the application process.
So I guess for me, like regarding the application process, so for me, like I actually applied twice to MIT Primes because the first time I did not get in. So my sophomore year I did not. So I tried again junior year and I got in. And I think the sort of what helped me a lot in the application process is like, especially in the math section, I needed to brush up on some of my like skills with probability and counting. So I did some practice with that to get ready for the next application cycle. I also think that you have to also solve some computer science problems. I think a lot of the courses at KTBYTE prepare you well for some of those because they ask you some like algorithmic questions, like they give you a prompt and they want you to write an algorithm that does a certain thing. And I think like in KTBYTE you do a lot with you do a lot, especially in like the CS01A, CS01B. I think those types of courses will be helpful, just making sure you know how to use algorithms and to solve those computer science problems. So that's what helped me, I think, a lot.
Awesome. Thanks, Maddie.
Yeah, I think going off Maddie's answer, I think the problem set's definitely the largest component for me as well. I applied once in my 9th grade, and that's when I got in. And so I think the biggest thing for me was that I think KTBYTE teaches you a mindset, at least, of how to problem solve. And I think that's what the Primes program is mostly looking for. Instead of just like getting a simple answer, it's like how you approach that. And so I think your methodology and everything you learn in KTBYTE definitely really helps you there.
Yeah, I'd like to second that. I think like it's definitely the way that KTBYTE teaches you to think. You don't hear a lot of that in your regular school about how to like approach problems that you really haven't heard of before and you know nothing about, and it seems so complicated and you never hear about like, well, what do I know now? And so for MIT Primes, you really need to like learn from your mistakes. So if you've applied before and you didn't get in, then learn from your mistakes. Like don't apply again and not try something new. Like Maddie said, you have to try and learn from what you've done and take that experience. And in the same way, in KTBYTE, if you ever approach a problem in a class, they teach you to learn from your mistakes because they explain how to do the problems afterwards. And they explain them very in depth. So taking that experience is definitely necessary for the Primes application.
Awesome. Thanks so much, everyone. And because we've only talked about in the abstract, I was curious as well, once you got into Primes, what was your research experience like in general? How was your experience with the program?
I guess in the beginning, it's a lot of getting used to. I think you're sort of thrust into a project. And so in the beginning, there's a lot of experimenting, but I think with your mentor, they really guide you through everything. And then I think I will say it is a very rigorous and time-consuming extracurricular. And so I think it says you have to dedicate 10 hours per week. And I think that's definitely true for that. But I think it's definitely manageable. And I think if you really love CS and you enjoy doing this sort of research, it's definitely a beneficial experience.
I think one thing to note about my like research experience in Primes, so you see on the website, they talk a lot about how research is very nonlinear. And when I was applying, you're kind of like, yeah, whatever, like that's what they're saying. But then you actually go in the program and like you start to learn very quickly that like when you're conducting research, you have to be aware of the fact that a lot of the work you do is going to sort of end up on the cutting room floor because there's a lot of ideas that don't flesh out into a final result. There's a lot of programs you write that end up not factoring into your final paper. There's a lot of, math you do that you don't end up using. And I was not like, that was very surprising for me to be working in that sort of setup where like, you have to kind of just go with the flow and like, trust that you're going to get something out of it in the end. But yeah, it's also a pretty important skill to learn to be able to like to be able to deal with like a lot of your work ending up on the cutting room floor. It's something I was not prepared for, and I learned the hard way, I suppose.
You especially have to learn how to make use of what your mentor says to you. I mean, no one can expect a high schooler to understand how to do research. They've never done it before. And so going in with the mentality that you're going to be able to do everything like completely alone without asking for any advice, and you're just going to do it perfect on the first try is never going to happen. So you have to make sure you're asking your mentor and like communicating with them and taking their feedback. And I mean, they're very welcome to taking to like helping you out. So don't forget that. Like ask for help. They're there to help you.
Awesome. Thanks so much. And kind of tagging off of that, it sounds like that could be one challenge of doing research, at least coming from maybe some classes where you're doing more direct problem solving and you can see a correct answer at the end of each problem. What other points are challenging about getting into the research world after taking more general computer science courses?
I mean, I think also another challenging thing is you have to start reading literature, because like before, when you're just learning computer science, like in a course, you have a teacher who tells you how to do things and you do it. But when you're conducting research, the whole point is you're on the kind of cutting edge. So there's no teacher who's going to sit there and like methodically explain everything to you. You have to sort of be able to like, well, with the help of your mentor, of course, you're going to have to be able to like navigate the literature and like read it and understand it, and then be able to build on what the current literature is and like produce something of your own. And so that's something also you have to be sort of just know that's how it's going to work if you're interested in research. It's in many ways it's different from a classroom setting where you have a teacher. Research is like a whole other challenge.
Especially when it comes to reading papers, even when you start reading them, they assume you have like a baseline understanding of what the research is like or what the field is like, which you probably won't have. So learning how to not only read papers, but find references to understand what the paper is even trying to tell you in the first place is also very important. And I think the primes application process also gets at that as well, because they usually have a theme for their problem sets. And so you have to learn how to learn about that theme without someone explicitly training you in every single aspect.
Yeah, I think to build off of that, I do think seeking help is a big thing as well, since you do have a mentor who will guide you through the process. And I think a lot of these skills you develop on your own, but I think having that mentor to help you out when you're really confused is definitely a crucial part of the process.
And I also think that like when so on the problem set, the problem set is good at like conditioning you for seeking help, because there are some questions where like you're gonna open up the problem set and you're not even gonna know what terms they're using. Like there's maybe some math phraseology that you don't understand, and the reason they put that on the problem set in a lot of cases is because they want to condition you to be able to like go on Google, like specifically to just go on the internet and like type things you don't understand, because that like doing that, especially in research, is a very important skill. Like when you're reading a paper and you don't understand something, that there's something you don't understand, there's some term you don't understand, like they want you, like primes want you to be able to just have the independence to go on Google like specifically and just type it and learn. So there are a lot of problems that are like styled that way. Like last year they put a problem on the problem set that was a solved like open problem, like finding the minimum bounding sphere or something, I remember. So they wanted you to like go and research what existing solutions there are to that, and like and basically compile them and like figure out your own solution, but like based on what you see online. So they're really conditioning you to be able to do that. It's an important skill.
Awesome. Thanks for tying that in, Maddie. I think one of our other questions is what outside of real world skills does research involve? So we've talked about being able to Google things, kind of a universal skill, but what else do you see as not being necessarily computer science related, but just a general skill you should have to enter this world of research?
I'd say collaboration by far, because you can do an independent research project with MIT primes, and a lot of the time that's what people want, but you can also get put with other people. And sometimes those projects, like they turn out, it's a lot easier to do well when you have another person because you have someone to bounce their ideas off of. Okay, I'm free to admit that like when you're a high schooler faced with a PhD student who's very experienced in a subject, it's going to be intimidating. Like there's no going around that. And so having another person to work with and being able to actually utilize the fact that you're not alone and you're with another person who's kind of starting at the same level as you, learning how to collaborate like that and making sure that you are covering all the bases of your research project without overworking any one person. That skill is really important during research. even if you are just working alone, learning how to leverage your mentor and make sure that both of you are committed to this project and you feel committed to this project, and getting that across to each other is something very important that can apply to a lot of things, but especially in research.
I think I'd like to agree with Tanisha's answer. I think a close second, at least for me, was learning patience. I think we often expect research to be a lot easier, but as Maddie said, it's a very non-linear process. And so you'll sometimes spend like days or even weeks working on something that in the end is like a dead end. And so I think learning to like get over those like difficulties and having the patience to debug everything is another useful asset to any skill, I guess.
Yeah, I mean, definitely both those are important. I guess something also like specific that I've sort of used my computer science skills like in a different setting. This is kind of specific, but like one time I wanted to build like a trebuchet, like a a catapult that launches rocks, and I wanted to understand like how what dimensions to build the trebuchet with. So I actually like used code. I wrote up a simulation of like a trebuchet, and I put in the algorithms to describe it and whatever, and that allowed me to get a better idea of like how I should build my trebuchet. So in addition to like learning patience and also learning how to communicate with people you're working with, there's a lot of like hard skills I think that like doing computer science and like doing computer science research in general, that it really ties into like other fields. Like in that case, it ties into engineering, that it's not just about hunkering down and coding. There's a lot of applications.
Awesome, thank you all. And I see one sort of logistical question in the chat, which I was typing an answer to, but just want to check in with all of your personal experience as well about the sort of age range to apply for MIT primes. I know on their website they say it's open to all high school students, but it sounds like most of you were accepted and participated as either a sophomore or junior. Could you speak to that a little bit?
You can still get accepted as a senior, but be aware that if you're accepted as a senior, you're only working for half the year. Because usually in primes, if you apply in November, applications come out like early of the year, like January, November, I don't know. And you're supposed to work through the summer until the next December. If you're a senior, you're going to be working until June. You do your presentation, and then you're in college, so you're not part of the primes program anymore.
Mm-hmm. Awesome, thanks. Yeah, I feel like that's a pretty clear-cut answer, but whoever asked that, I guess everyone can see this. I sent the apply page from MIT Primes as well, if anyone's curious. Great. Getting back to our seminar questions a little bit, I'm curious about all of your broader experience as students and how some of you are high school seniors, some of you are college freshmen, and thinking about your CS experience in general, what are the skills or portfolio pieces that stand out as things that are helpful for those kind of college applications?
So, I mean, I'm still in the thick of college applications because I'm a senior in high school. But I guess, so things in terms of computer science that I've sort of integrated into my college application. So obviously the primary one would be my participation in MIT primes. Also, I mean, I've taken several courses through KTBYTE that I've worked in, that have helped me a lot in Java. I've also taken some courses in machine learning, not through KTBYTE, but through Coursera, that were helpful for me for understanding just, I guess, the basics of machine learning and deep learning. So yeah, I guess that's the bones of what I've got for it.
Yeah, as a college freshman, maybe I can help a little bit more, but I would say to a certain extent, once you have like maybe 3 CS portfolio pieces or something, it's kind of like adding 5 isn't really going to change much. So for college applications, the college mostly just wants to see that like you know what you're doing and you understand that you want to do this and you're very committed and you're intelligent and you are willing to perform well at their school. So in sort of abstraction, you just need to show them that you have CS skills. I think doing KTBYTE classes, performing well in those classes, doing MIT primes and performing well in MIT primes, getting results. Because if you do research but it doesn't go anywhere, then it doesn't entirely show your capabilities, because you have a capability to present at a conference or present a poster or something. So making sure you get those results that they can actually see. Oftentimes the people who are reading your applications don't actually know most of the hard coding stuff. So you need something that's a little bit more tangible and understandable for them. And then also just showing that you know what you're talking about and you really care and that you're going to perform well if you go to their school. That's what most of the college application process is about.
Awesome. Thank you both, kind of from both sides of that process. I think that's really helpful. I did see another question in Q&A about KTBYTE class levels and competition specifically. And so I can speak to the ACSL part because I don't think many of you have competed in ACSL, but the ACSL Junior is the division that most students join at around 6th grade. You could join younger if you want, but you can no longer be in elementary as of 6th grade. And so depending on your age and also KTBYTE course level, I'd say is roughly equivalent to CS00A or 00B. And we do offer an ACSL Junior Prep Club as well. I can send the link to that in the chat. So that's the ACSL side of things. Of course, you can keep leveling up through divisions as you choose or as you age out of them. And the USICO is a little different. I know we have more USICO experience in this group, so I won't say too much here, but you can try the USICO bronze competition whenever you want. You need to do recently very well at bronze in order to get promoted to silver. And in our courses, that's roughly equivalent to the CS02A level of classes. So once you finish CS01B, that is when most students will start USICO prep. But I was wondering if anyone else here could speak to that as well, just your experience with competition prep.
Yeah, I think I did USICO actually pretty late. I did it in my sophomore year, I think so. I'd already had a lot of experience with CS already. I do think bronze, there is a KTBYTE prep course, and I think the bronze prep course does prepare you very well for that. And I think much of it is just like seeing as many problems as you can, working through them, and then until sort of they become second nature to you and you can just recognize them when you're actually during the competition.
Yeah, I mean, I would say the same thing. Like, it's very useful for the KTBYTE classes. I think they also have the help courses, correct me if I'm wrong, like the study groups for USICO problems. And like the classes themselves are also very useful because not only do you get exposed to very many different types of problems, but you also get to hear from the instructor's side of how to approach these problems and how to think about them. And you are working alone when you're in the competition, but kind of during the classes, you get a lot more of a chance to hear what other people think, which expands your view on how computer science can work and just makes it a lot more useful.
Yeah, I mean, I agree with what Tanisha's saying. I think the KTBYTE courses. So I did the like USICO Silver and the USICO Gold KTBYTE courses, and I think they were pretty helpful because like you can sort of get feedback from a teacher, because if you try to self-study for USICO, it's a little difficult because you might not know how to solve a problem or like get the solution that's fast enough for them. But you know, the teacher kind of knows how to do it, and it's helpful to actually have a person there explaining it to you because these problems can be pretty hard in USICO.
Awesome. Well, thank you all. I think that ties together nicely some of the other advanced topics we see with computer science. And I'm curious as well, now that you've done or are still doing the research track and looking forward to college, maybe beyond college, just what other fields or experiences interest you with computer science? Basically, what goals do you have to keep using this knowledge?
So for me, in addition to being interested in computer science, I'm like pretty interested in linguistics and like language and stuff. So there's a lot of computer science that's dedicated to either understanding natural language in a field called like natural language processing, and there's like computational linguistics, and you can sort of like analyze the evolution of language through our time. So there's a lot of things you can do. My point is there's a lot of things you can do with computer science. You can apply it in a lot of different ways because it's such a fundamental field of study. And I think that's what makes it so appealing.
Yeah, I think for me, what I hope to apply it is more in the biology field. I think since I've been taking a lot of biology courses at school, and so I think bioinformatics is definitely one of my interests. I do know that Primes, I think, offers two tracks for computer science. You can either do like pure computer science or bioinformatics. I think at the time I did pure computer science. I'm not sure if anyone else did bioinformatics and if they can speak more on it, but yeah.
Oh, funny you should say that. I started, my first Primes project was in computational biology. I decided that I wanted to do more computer science, so my next Primes project was in computer science. That was mostly in the systems side. And then now that I'm in college, I've decided that I kind of want to do more music processing and voice processing. So that's where I've led. It's mostly, I'm more interested in just seeing like everything computer science can do. I haven't narrowed it down specifically that much. So I'm just like trying to see what computer science has to offer. I've seen some of it so far, but there's always more.
Awesome. Thank you all. And yeah, I think keeping that attitude of curiosity and yeah, you're never going to be done learning things, but that's a good thing, can be a really powerful outlook to have as well. And yeah, before we wrap up sort of our panel questions and head on to the parent panel questions, I know we've talked a bit about competitions, coding competitions as another advanced pathway you can follow. I was wondering if, other than the research we've spoken about, competitions, anything really stands out as a sort of advanced CS pathway that you've been excited to get into recently, whether that's like pure CS knowledge or robotics or any other application that's been interesting to you.
I mean, I'll just say my research project, I've only just recently started it, so I'm very interested to learn more about that. It's in Python, which is a language I don't code in very frequently because it's mostly for machine learning, which I didn't do a bunch of. So I'm very excited to learn more about that and see how that works.
Yeah, I think for me is I'm actually just moving on more into machine learning territory and sort of data science as well. So I think since now I'm taking courses like linear algebra, and so having that math foundation to work into more advanced topics in CS is definitely something I'm looking forward to.
Yeah, I mean, also going off what Alvin said, I've done some stuff with machine learning on my own, and I think it's pretty interesting. I've used, as he said, some linear algebra because there's a lot of matrices involved in describing the data that you need for machine learning. But yeah, I mean, I would recommend definitely just pursuing machine learning. I get, and KTBYTE offers it, but just pursuing it like as an advanced track is like it makes a lot of sense because it's very interesting, and it is an interesting branch of computer science, I guess.
Great. Well, thank you all so much. I'll turn a focus on to parent questions here. And I know Wendy just sent me one that's from our YouTube live stream, which is very exciting. We haven't used that feature much in the past. And then, of course, I have all the registration questions as well. But feel free to keep using the Q&A feature. And then if you're a panelist and feel like typing a response or answering one of those live, you can do that as well. But the YouTube question we received is, and this actually might be a better one for me. It's, can KTBYTE help with applying to MIT primes? Actually, I think some of you may have reached out to us for references at some point. I actually can't remember exactly how that process works. We're happy to mentor students, especially our teaching assistants, is when we typically say we can like provide references or letters of recommendation to you and help guide you through the process. But I don't think there's so much we can do in terms of, you know, sitting down with you to complete the application. But I'm sure you three can speak to your experience as well.
Yeah, KTBYTE wrote a recommendation. KTBYTE wrote a recommendation for me, but according to the rules of the primes application, you're not allowed to sit down with another person and get them to solve it for you. So it is entirely dependent on like the student themselves for that. But like, yeah, the KTBYTE recommendation, I think it shows that you have a passion, which is what primes at the end of the day also really wants to know. It's not entirely about just solving the problems. It's about showing that you have a passion, also that you're going to represent primes well. So the recommendation helped with that for sure. Cool. Thank you by the silence and the nods that Alvin and Maddie had similar experiences. And yeah, I guess from more the admin side of KTBYTE, to speak to that a little bit, the better we know you as a student, the better we can help you out with that letter of recommendation. I think a short letter of recommendation is almost worse than no letter of recommendation because people know a form response when they see one. But that said, if you've taken our advanced courses, especially if you've shown interest in being a teaching assistant or been really engaged in class, I'm sure we'll have had enough interactions to write you a good letter. But thank you, whoever submitted that. Moving on, I saw this one pop up in the Q&A towards the beginning, and I feel like it might be a more complex response, so I'll answer it or ask it here. But this also got asked in the registration. So what kind of math background is really helpful to have for MIT primes? And I think this participant asked specifically about math competitions like AIME or AMC 10 or 12, which I'm less familiar with. But yeah, I was wondering if you all could speak to that in general. What kind of math knowledge is helpful for getting into this?
So I guess for the math on MIT primes, I think what's interesting is like, so on a lot of competition math that you'll see on the AMC 10 and the AMC 12 on the AIME, you'll see a lot of like problems that don't necessarily take a lot of time, and they're designed that once you kind of know the trick, you can solve them pretty effectively. And so that they're kind of quick problems in a way. But I think primes is actually looking for a markedly different type of problem solving ability, which is sort of the ability to have like the stamina to push through a problem that's like longer and doesn't have a clear solution. So if you go on their math problem sets, like the problems aren't like taken from the AMC. They're not in the same style. The problems you'll see are generally longer, and they want you to provide your solution, not just a multiple choice answer. So you have to kind of write it out, and it's probably going to take at the very least several days of thinking to be able to like flesh out your problem and solve it. Because the reason they're looking for that, obviously, is because in the actual research process, it's not helpful if you can just solve like quick problems with like tricks quickly. You need to be able to sort of be able to sit and like think for a while and like gradually approach an answer. And I think it's a very different skill set. So obviously like all math experience will help. I think though that like experience with the AMC is not like going to be directly correlated with the kind of stuff you'll see in primes, I guess.
Yeah, I think I definitely agree with Maddie's answer. And I think sort of what you learn in school is honestly, I think more helpful, and being able to Google those answers. I do think since I applied in ninth grade, I had taken AMC 8. I do think learning a lot of those tricks will help you a lot though, since you can more quickly recognize similar problems and do them. But I think even if you don't have a strong experience in competition math, you aren't, I think, at a significant disadvantage.
Yeah, exactly. I think Maddie and Alvin hit it on the head. Like, I didn't have any math competition experience. I think I did maybe one exam, and it was a practice too, so I didn't really do that. But it's exactly like Maddie said. It's about your inherent problem-solving abilities and your willingness to stick with it. There's no like causation between, oh, you do well at AMC, you're going to do well in primes. It's entirely up to you. So if you didn't do well in AMC, that doesn't mean you're not going to do well on primes. It just means you thought different.
For sure. And a similar question that popped up, other than linear algebra, what other types of mathematics do you find are key? It sounds like that, like you said, inherent problem-solving ability is really what matters there. And I might make a guess that the type of mathematics you want to have as a background might depend on like what kind of research you want to get into, or if you're generally excited about doing more of that kind of math. I don't know if anyone had more specific experiences with certain types of math and MIT primes.
I think
Yeah.
if I remember, sorry, you can go first. There you go.
Okay. Yeah, I was just going to say, I guess, regarding specific types of math, I mean, in the application process, usually the most helpful type of math would probably be probability, like that sort of thing. For some reason, a lot of the questions just seem to be focused around computing expected values or probabilities. Sometimes they'll ask about like other stuff. Like weirdly, I believe one year they asked about like Galois fields or something, like something very weird. But like the whole point is, since you can Google, and like if there's some math you don't understand, you can Google it. It's not such a big deal if you haven't like studied college math, because they're really looking for your ability to do research on your own. So the math is stylized around that.
Yeah, I think I remember my year counting on probability was another big one. I think there's a fair bit of just like standard algebra and sort of manipulating equations, summations, and everything like that. So I think that's definitely important. I think in general, as Maddie said, it's being able to Google things. You don't need like a super advanced level of math background. I think it's just being creative, knowing how to like approach these problems. That's more important, I guess.
Awesome, thank you all. And I'll count that as the answer as well to the one that just came in about does the eligibility for applying need to meet any of the following criteria: USMO or USA JMO qualifier, select a math summer camp, college level math course from college. Sounds like no, but none of them would hurt. If a student takes advanced math, also I'm sure wouldn't hurt, but don't want it to sound like any of those things are prerequisites. If you're coming into this with a strong CS background, excitement to learn and do research, they don't have requirements along those lines. There was also one that I believe Wendy typed a really helpful response to, but just wanted to point out, you're talking about being a teaching assistant at KTBYTE, and if any of the panelists want to speak to that experience, look at that opportunity as well. The requirements, which I actually do most of the hiring and managing of TAs here. It's typically students who have completed our CS01B level course, which is roughly a AP computer science level. If you're coming in with that level of knowledge, we have had TAs apply who haven't taken our classes but want to work with us, and sometimes that works out as well. But yeah, that's the most important prerequisite, just having that's solid background. If our teachers know you, that's definitely a plus. And then just having the availability to meet for some trainings and feel out the role before deciding if you want to commit to it. But yeah, I guess this is more of an open-ended question, but do any of you have things you'd like to speak to with your experience as a teaching assistant or as an instructor here?
If you have the opportunity to be a teaching assistant at KTBYTE, I'd say it's like inarguably the most useful thing I did during my high school career, maybe even more so than primes, just in terms of how much I learned. Because like the inherent nature of being a teaching assistant or being an instructor is being able to answer questions that you haven't heard before. Students are going to ask everything, and students are going to ask very in-depth questions because some of them just don't understand the fundamentals because you're teaching it to them. And some of them are going to ask questions you've never thought of before, but you're going to need to know how to think on your feet and how to approach those questions. Even if you don't know the answer to a student's question, learning how to help them find the answer themselves or helping yourself find the answer and then help them in return. All of that was so fundamental to my problem solving skills. So it's definitely a worthwhile opportunity.
Great, thanks, Anisha. And yeah, just to speak a little bit to this new question, what does a KTBYTE do? Do you get paid? Yes, you can choose to have it as a paid position. Some TAs choose to count it as volunteer hours or work for KTBYTE credit that they can use for a course. But it is a real job. We do want it to kind of stand out that way and have that weight both for the student and if you want to use it on a resume or something. And typically you're either helping out with one of our online or in-person group classes and supporting the instructor, helping students answer their questions, or even more common than that is staffing our help hours. So if your child is a KTBYTE student, hopefully they've tried using our help hours at some point. They can be really useful. And students will come in with all sorts of homework questions from basically the first 5 levels of our classes, which is why you need to be fairly advanced to work as a TA. And your job is to not just help them get to the right answer, but help them understand how to get to the right answer in such a way that they could do it themselves in the future. Coming back to a few of our registration questions, and we don't have too many of these left. One of them was opportunities for remote learners. So that's something I can speak to in a bit with our KTBYTE classes, which are very remote friendly. There's also Primes USA, which I don't believe any of you 3 have experience, but just in doing my own poking around in the internet, seems like it's a pretty comparable remote experience to MIT Primes. And other than that, let's see. There is a good question of where did these research project ideas come from? Like when you're getting into the research program and picking a topic or being assigned a topic, where does that come from?
So for me, my topic was, it was interesting. So my mentor is really great. She provided me, she started me on a bunch of, on a group of papers, and I just read through them, and she sort of guided me because there's a lot of different trajectories we could have taken the project on. We were thinking about something called federated learning or distributed learning, or reinforcement learning, various types of dynamic programming and machine learning. And she sort of really lucidly presented me with options and explained to me what they would be like. And over the course of about, I'd say, a month, I sort of figured out what I wanted to focus on. So basically, I'd say that the idea for what you're going to research is a mix between what your mentor, how your mentor helps you through it, and what you personally want to do and what you are interested in. So it's a pretty good balance, I think.
Yeah, to build off that, I think once you get in the program, your mentor will have, I think, a specialization in a particular field, and so they can guide you towards that direction. But then how exactly you want to take it, I think, is largely up to you. And so sort of seeing what knowledge gaps you want to fill and then how you solve everything, while they guide you through, I think it very much allows for your own creativity.
Great, well, thank you both so much. And I believe we've talked a bit to the role primes can play in college admission, so I'll just pose the answer to that live. But it sounds like having some really strong portfolio pieces, and probably you don't need to overdo it with so many strong portfolio pieces, but just 1 or 2 that show you're really passionate about a subject area can be really helpful to college admissions, as long as you don't expect the person in the admissions office to understand all the minutiae of your research project. And yeah, circling back really quickly to USICO, I know that came up both in the registration and then in a question here in the Q&A. sounds like you all have experience preparing for USICO. What did that look like outside of KTBYTE classes? How much preparation did you do on your own?
So when I was in the thick of like doing USICO and preparing for it, it definitely took a lot of time. Like if there was a competition coming up and I was really motivated to maybe promote or something, I would probably maybe spend at least like 3 hours a week just like looking at the problems, trying to write code, submitting it, it's not working, blah blah blah. Like I did a lot of that, of just independent practice. If let's say you're in silver, you want to promote to gold, I would just go onto like the USICO website. They have a ton of practice problems. You take the level that you want and you just try to do them. You can submit them, and yeah, over time you just learn how to solve it like that independently.
Yeah, I think it also largely depends on the level you're at. I think the KTBYTE courses I think do help a lot, but as you get into higher levels, I think much of it is self-preparation, especially if you're at gold and you want to get to platinum. I remember I think that jump for me, I think required a ton of studying. And so being willing to put that effort in definitely really pays off in the end.
Yeah, exactly. Once you get exposure to the problems, it's more of a manner of you just like learning more about them and remembering the stuff that you learn. So just hearing someone talk about it, it's great and it's very helpful, but you're gonna have to do more on your own. So as Maddie said, and as Evan has pointed out, just like looking at the problems, doing the problems on your own, spending time, and like if you can't do something the first time you do it, sit down, like go somewhere else, come back to it. Like just try and get through the problems and again be persistent.
Awesome. Well, thank you all so much. I'll start to get into kind of our outro here, just the last few slides I wanted to share. But I'll give you all a chance to say some words of closing if you'd like to towards the end. Here I am just going to share my screen again for a second with the Primes presentation link that you all so kindly shared with us. So we have here all the Tanisha, I could only fit one screenshot of your two projects, but we have a screenshot from each of your 3 slides presentations and the links to the presentations themselves, which will be shared after this. So thank you all for sharing your research with us, if anyone, or especially for parents, if your children are interested in seeing what can come of this pathway. Even though these can be a little technical, they are something like you would make in one of our advanced courses, so not out of the question for someone getting into high school research. They also can take a while to load. So I'll share these links in the slides, which you'll all receive in an email. But if you have a specific request for one of them right now or all of them, let us know in the chat. I can definitely copy and paste these links. And then tying that in with what KTBYTE does, we have some research opportunities here, mostly through our machine learning course progression. So these are courses that we've had for a while and are currently being revamped just to make them a little more user-friendly and have more reporting on them. So you'd get like progress reports and grades, which didn't always happen before. And the one we're running right now is just about to get into research projects. So doing things like image classification, text classification. We've learned most of the basics of machine learning algorithms this term so far, so giving students a chance to specialize a little bit. And most of those will end up on the projects page of our site. So this one, I do believe will load, and I can share the link. You can see Tanisha's is on here. I think Alvin, you have one on here as well. And they're all just pretty concise, readable presentations that are nicely laid out like this. Can be really great if students need a science fair submission or something like that to take this course and then use it to create something like that along those lines. So feel free to use this as a resource for ideas, especially we're talking about how do you get ideas for resource. So one great way is looking at research that other people have done. And of course, if you have questions about our specific courses or what happens in them, we're happy to answer those in the chat or over email. Another one that is similar but didn't come up, just happened not to come up in our presentation, is robotics. So our robotics clubs do provide a way to get into pretty advanced design and computer science work alongside the mechanical component. And yeah, it just so happens that our students have won a lot of national awards in those fields as well. So it's not like doing primes research or doing research in general is the only way you can get into a more advanced track with computer science. And so those were most of my points. I actually forgot to share an entry poll, but we'll share an exit poll now, which is basically just asking you for your feedback. I think one of these actually has an old question on it, so please ignore the one about competitions, but do feel free to let us know if you'd like to be contacted for more information. We're happy to do that. That exit poll is live. If you could answer it before you leave, that would be awesome. And I believe we have one more Q&A. And oh yeah, it's kind of circling back. How about the challenge of being accepted to primes, or kind of how selective it is? Yeah, maybe we'll pose this one to our panelists, and then if you have more to say just in closing, you can say that as well. But starting with that final question, how challenging is it, or what's the selectivity like of getting into primes?
So, okay, so I think like regarding selectivity in primes, so primes doesn't release their acceptance rate, I think. I think because they don't want to like discourage students from applying. So there's no way to say like overtly what the acceptance rate is. But I mean, based on my experience, it's like like moderately selective, like maybe like 10-20%, although that's just a guess. I don't really know. Because you do like they do want you to put in a significant amount of time into the problem set. It's not like a one and done fill out the application and then they either accept you or not. Like you need to kind of have a plan in advance and like know that you want to do it, and like know what you want to do so that you can complete the problem sets and do well enough on them, because that's what they look at the most. And yeah.
Yeah, I think it'll definitely take a lot of work and maybe even repeated tries as well. I think around 10 to 20 new students get in each year, approximately. I don't know how many apply, but from like what I've seen, that's generally the number for new prime students.
Yeah, I would say it's around like maybe 10%, maybe a little bit lower. I don't know if I'm exaggerating, but yeah, they accept more people mostly because they get more applicants. And I mean, it never hurts to try. Like you can't get rejected if you don't try. You can't get accepted if you don't try. So like the focus there is like, even if you do get rejected from primes your first time around, like just do the problem set again. You can get accepted again. It's never over.
Great. Well, thank you all so much. There was one final question about the TA role, if there's an age limit for it. There is no age limit, just that competency requirement of CSO1B or similar level of experience. That said, there is a interview and orientation component where if you're very young and depending on your maturity level, if your maturity level is more on the middle school side than the high school side, we might just tell you to wait a term or two. But there's no strict age limit for TA. And the last question I can answer live as well. We don't currently have a CS84 running, but we will in the spring. So we are accepting time requests for that. If you know your student took our CSA2 course or similar material, they know some machine learning, and they'd like to take CSA4 in the spring, please send us an email or fill out the time request form on that page, and we'd be happy to take that into consideration for scheduling. Great. Well, thank you everyone so much for attending. And I guess panelists, if you have any closing thoughts or things you'd like to share before we stop, now's a great time.
I guess maybe the biggest thing to take away from this panel would probably just be that primes isn't necessarily looking for just your numbers. They don't want to see like, I just did competition math, or I'm used to go platinum, or like, I'm really good at AMC 12. Like they want to see your passion and your persistence. They want to see what kind of person you are. So even if you feel like you can't solve a lot of the problems, they do ask that you write comments and you write down your thought process. So even if you're struggling, if they know that you have potential to do well, they will support you.
Yeah, I definitely agree with that. I think methodology is a lot more important than just simply getting a few results out. And so I think if you're applying this year, best of luck and keep working hard.
Great. Well, thanks everyone so much. And thank you to all our participants for attending, for giving us great questions to respond to. Again, everyone who attended, and even if you registered and did not attend, you'll receive the recording and the slides. So hopefully this can be a resource towards you going forward, and we're happy to have more conversations either by phone or email or WeChat as well.